Aloha, Rich Halverson here. This is ICS211. And today I'm going to continue with chapter 4, try to finish it up. So let me share my screen. Okay, so it looks like clicking on my activity, looks like nested loops is next for me. All these other ones are optional. By the way, really this book is designed and this course is designed for you to work on your own. So, you should be ahead. Some people, 2 or 3 of you have emailed me and asked me about the schedule and what schedule am I following. The syllabus is a good pacing schedule. So you get through one, every day you do something, get all the way through. But really, that's a lot of people. They do their regular job, take care of their kids during the week, and then maybe the weekends they jam on a few assignments and a few days. At that time, that's fine. These lectures are designed if you're stuck, and you come here and get pretty close to the answer. I want everybody to get a good grade, even if at the end of the semester you don't feel like you got it all, and maybe computer science isn't for you, maybe MIS or there's other closely related fields where if you've gotten through 111 and 211 and you know how to program, you decide you don't want to be a programmer for the rest of your life, then I want you to learn and still do well in the class. All right, so let's go to nested loops. All right, so a nested loop is simply a loop inside of a loop. And you see there's a loop inside here, up inside of another loop here. And it looks like here we're just figuring out what all the 2-letter domain names are. So we start with A, and you notice that for the first 26 of them, they're all A. Start with A, and then they start with B. Well, A is the outer loop because we do the printing inside the inner loop. So this inner loop is going to print 26 times while the outer loop is an A, and then the outer loop goes to a B, and then the inside loop is going to print 26 times. Each time the inner loop prints, it increments the second letter. So anyway, that's why it looks like that. Inner loops, when you're counting the computational complexity, have we gotten to that? Yeah, never mind. So let's do a challenge here. Integers first range and second range are read from input. Complete the inner loop. So the inner loop executes first range plus 1 times second range plus 1 times. So if you look back in here, the inner loop, this thing executes however many this is times however many this is. So that times that. So you count that way. You multiply them together. So that's why they simply say we have an outer loop, which is first range is when I goes from 0 to first range, and then inside goes from 0 to second range. And if this is correct, and it actually does go first range plus 1 times, then I would have to guess, let me start this up. I would have to guess that this can be J is less than or equal to second range. Without thinking about it anymore, I bet you this is the right answer. Now watch me be wrong. Yes. All right, what's next? Here we've got first num and second num again, read from input. Complete the inner for loop so that the inner loop executes first num times. So the inner loop executes this many times. Let's see. This looks like the outer loop. You're right. This just executes first num times, because when you go to 0 to first num minus 1, that's first num times. So that's what that is. Now this one here is going to do one more than that. More than that. Like do I use J? Ah, there's a clue. It's initialized a J for me. J equals 0, semicolon. J is less than or equal to second. So, and I just like this J plus better. I think plus that was. I'll probably get dinged sometime for that, but let's see if this is right. Maybe this is the time I get dinged. Guess not. What's next? Integers. Oh, here we are again with first and second value are read from input. That's all they give us this time. For each number from first value to second value, output the number's value of equal sign. Here. Oh, that's clever. So if the input is 5, oh, I see. From 2 to 5. 2, 3, 4, 5. So it's from 2 to 5 inclusive. So let me go for why they give me I and a J. For I equals first value, I is less than or equal to second value, I plus plus. Oh, I see why they give me a J. For J equals 0 to J is less than I, semicolon, J plus plus, system dot out dot print, an equal sign, after which print line close the first for loop. This for loop does not need curly braces because there's only one statement, and you use curly braces to make many statements into one statement. We're going from 0 to I minus 1. We're not gonna go all the way to I, because we want I number of equal signs. After they're done, we want to put the print line there, and we're going to go from I first value to second value inclusive. So that we're going to start out with the first value, and we're going to go up to the second value and include the second value. So let's see if this is correct. Yeah. All right. Very good. Okay. So what's the last one? I'll just tell you how to do the last one, and then you can leave. So in a cinema, each seat is labeled with an integer followed by a letter. Given integers num rows and num columns, output the label for each seat followed by a space. End each row with a new line. For example, if the input is 2, meaning 2 rows, and 6, meaning 6 columns, then the output is the blah. How do I print the letter? How do I print the letter? Does it give me a hint? All seats start with 1. All columns are alphabetical order. Seats in the first column all end with the letter A. Doesn't give me any hints, huh? Oh, what is this letter business here? Oh, look. What? What? Oh, let's see. What is this now? Letter. Oh, I can just do that. Oh, it starts with a single. All right, let me see if I can do this now. um, or I equals 1. I is less than or equal to. I'm doing rows first. All right, I goes from 1 to 2 on num rows. From 1 to num rows. Well, I'm going to go from 0 to num rows. 0 less. Okay, because I want to start accounting at 0. You'll see why. I plus plus. For that, do this. It's the current row. All right, well, I'm going to use this for that. Boy, this is a long one. Okay, so that's going to be the current row integer, current row plus plus. Okay, and then so there, it might be an advantage. I don't know what's going to happen with it. And then there's going to be an inside one, which is going to be for current column. For the current column, well, if I get, I'm gonna have to just do this one. If I get it right, I'll be amazed. Current column equals 0. Current column is less than num columns. Current column plus plus. Inside there, we're going to print out, let's see. That would work. Let me go back to this. Let's see what this was here again. You would do a letter plus plus. Okay, letter plus plus just adds to it. Okay, letter plus plus. I'm going to do letter plus plus. I'm going to say current column letter equals A. And then I'm going to say from this to this to this, I'm going to say, and I'm going to say, I'm also going to say current row equals 1. And in here, I'm going to say print, system out print. Current row plus current column letter plus a space. Well, I'm going to put a space there. Plus a space. Okay. That's what it's going to print a bunch of times. Oh, I got to increment current row of current column letter plus plus. Can I just do that? I think I can just do that. And then we can close the for, the inner for, and we'll close the outer for. Oh, yeah. Oh, no. This has got to be current row equals current integer plus 1. Current integer goes from 0 to 5, and this is going to go from 1 to 6. Current column letter starts out with A, and then it prints it all out in increment. Let's see if this is right. Didn't get it right. Oh, look at it. I'm printing something out wrong. Current column letter. Current row, the current letter. Somewhere I forgot to put the print line, but no, I not only forgot to put the print line, but it's printing out. It's not printing out a letter. All right, well, let me do the print line. I need a system out print line. Yeah, I know this isn't going to do it for me, but okay, I'm gonna check here. Somebody was the right answer, right? All right. All righty, let's try this. We got to tell it right away that we want the plus sign to be a string. A plus sign means concatenation, not the plus sign means, because this is a number, it might, I don't know, I think that's just the numbers. So let's see what this does. Oh my, that's all it took. All right, well, great. What's next? Let's see. I would have thought that was okay, break and continue. These are helpful because when you're in a loop, especially like a for loop, and a for loop is designed to go till the end, it could be that while you're inside the for loop and you're not near the end yet, you might decide, gee, I don't need to do the rest of this for loop. So you can put a check in there, you can put an if statement in there, and you can use a break statement. Something is to break, and that breaks out of the loop, whether it's a for loop or a while loop. Okay, so that's what a break does. What a continue does is it says, skip the rest of this iteration, skip the rest of this pass, and then go up and see if it's ready to see, skip it and go up to the top. And if you do another one, you do another one. So what this does is, since this is true, it's going to skip all this stuff and go to the end of the for loop, which is right here. See, it's this for, and it's going to go back up here, and it's going to increment this and check to see if this test is true. So that's continue and break. Break breaks you out. Continue just skips the rest of the pass. Yeah, got that? All right. Let's try some challenges here. This time, I'm going to skip the fourth one, I think. Maybe I'll skip the middle two, and then I'll do the last one. All right, so what's the first one? Enter the output of break and continue. Okay, so we start out, it will read up a thing called stop. And we're going to loop. We're going to loop, we're going to go all the way up to, we're going to loop until this is greater than stop. Okay, we're adding up a value called result. We're also in a loop here, and we want to see how many times it loops. How many times it loops before result becomes greater than this. Boy, this is a tough one. Okay, so how many times? Okay, so the first time n is result is first time result equals result plus 2. So then result equals 2, and the next time result equals 5. Let's see, I gotta use 5. It's gonna be a slow lecture today. To bring up my whiteboard. Put this over here. Okay, where's my something to write with? All right, so we have result, and we have and we start out with result equals 0, and n equals 0, and then result equals n plus 2. Result equals we add to result n plus 2. N is 0, n plus 2 to result, and so now result becomes 0 plus 2 is 2. Adding 2 onto result equals 2. So now result is 2. And is result greater than stop? I better put stop here also. Stop. And stop is whatever we read in, which is 6. Okay, is result greater than stop? No, result is just equal to 2. So we go back up here again, and then we add 1 to n, and now n is equal to 1. And 1 plus 2 is 3, so we add 3 onto result, and adding 3 onto result gives us 5. And then is 5 greater than stop? No, it's not. So we skip back out again. But each time we skip out, we're supposed to print results. So the first time we went through here, result was equal to 2. The first time we hit this print statement, result was equal to 2. Okay. And the second time we hit this print statement, the result was equal to 5. Okay. And then we come back around again, and now n is equal to 2. And result is going to be equal to 5 plus 2 plus 2 is 9. So now our result is going to be equal to 9. And is 9 greater than stop? Yes, it is. So we go in here and we say n equals 2 plus 2 is 4 plus, yeah, n equals 2. I think the answer is going to be n equals 2. I hope this is right. And it's a print line. So first n was equal to 0, then n was equal to 1. Okay, let's see if this is right. Ah, what do you know? All right, what is, what's the next one? What's the program's output? Well, these are hard ones. Result equals 0. Okay, should we just do this again? So let's do this again. Move your eraser faster to make it bigger? Oh, let me try it. Let's see. Very good. Okay. Okay, so result is equal to 0. Okay, so we have result. And then we're gonna have n. And result starts out equaling 0. And n is gonna equal 0. Then results is gonna equal 0 plus 4. It's not, okay, results is just gonna equal 0 plus 4. It's not plus equal, it's just equal. And if result mod 2 is not equal to 0, then do that. Result mod 2 is equal to 0. Okay, so it looks like it's only going to print out numbers that are divisible by 2. Okay. So result is equal to 4. 4 mod 2 is 0. So go here and just print the result. So the result right now is 4. So it's going to print 4. And then it's going to come back around, and n is going to equal to 1. And then result is equal to 1 plus 4 equals 5. Result is going to equal to 5. And 5 mod 2 is not equal to 1. And not equal to 0, it's equal to 1. So I'm going to print this. I'll print this. That's an underscore. And then I come, and then I print hold it. Right here, I was not supposed to print the 4, was I? I was not supposed to print the 4. Okay, so I was just supposed to do the print line. So the space Wait, no, never mind, never mind. I was right the first time. I do print the 4. Okay, I always print the result, but sometimes I put an underscore in front. Oh no, continue means go all the way to the end of the loop. Skip the rest of it. Okay, so I think I was right the first time. It prints a 4 when the result is mod 2, when mod 2 equals 0. It prints an underscore when mod 2 equals 1. And then it and it always prints a print line after that. So now we're down here. And oh, this is a while n is less than or equal to 8 and n never goes up to 8. So I guess it's like maybe, how far do we go? We go all the way up to n is each time we're printing the result. Okay, so we go all the way up to 7 is going to be the highest one. So 7 plus 4 is 11. So if we go up to 11, I think, and then we're done. I think this might be it. I'm going to see if this is right. 0, 1, 2, 3, 4, 5, 6, 7, 8. But 0, 1, 2, 3, 4, 5, 6, 7. Seems like we should have one more here. Oh, that's right. Yeah, no, I'm counting. Yeah, okay. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Let's see, is this right? Oh. Oh, I'm not supposed to have any of the. Oh, the print line comes at the very end of the last 4, not of this. Oh, there is no second 4 to wonder. Oh, for some reason I thought the print line was right. All right, so now what happens to give me a chance? Yeah, it gives me a chance. Oof, okay, what's next? All right, I think I'm gonna close it up here and start a new video later. This has been about 15 minutes. Thanks for watching.